So let's finish up our example of using inheritance by adding two new classes of MIT person, two types of students. One will be an undergraduate student who will have a class year attribute, and the other a graduate student. So we'll think of students as a subclass of MIT person, so all students will have an MIT ID number. And of course, MIT person is a subclass of person, which means that all students will have a name and a birthday as well. Okay, so let's go look at the code. So here's our first draft of the code. I've defined two new classes here. An undergraduate who's an instance of an MIT person and has its own instance attribute, which is the class year, and a graduate student who's also an MIT person. And then finally, I've written a little predicate which allows me to detect whether an object is a student or not. And it does something fairly rudimentary. It simply takes the object that I've passed in and asks if it's an instance of an undergraduate or an instance of a graduate student. So let's just check out how this works. So I can say student 1 is an undergraduate whose name is Stacy, whose class year is 2015. And let's have student 2 be a grad student whose name is Justin. So far so good, and I can actually ask, is student S1? I can find out if Stacy is a student, and let's find out if Justin is a student. Okay, so all that works as expected. However, there's sort of a bug in what I've done, and let me sort of illustrate that bug by going off and creating a new class of student, a transfer student. Like so. Now what I discover is that my isStudent predicate is broken, because what I've done is expand the repertoire of students, and now I have to go change the behavior of isStudent to know that there's a third type of student, and a fourth type of student, and a fifth type of student. This is sort of an indication that my class hierarchy, my type hierarchy is broken, because what I'm doing is I'm starting to want to describe behaviors that are true of a set of types, and what I really need to do to make that easy is to define a new superclass. So I really should have started off by defining a class of student which was an MIT person, okay, and then gone off and made student a subclass, make undergraduate a subclass of student, and graduates a subclass of student, and transfer a subclass of student. And now I can finally change this code here to basically ask whether something is a student or not, an object is a student or not. So now that I'm thinking more clearly, I realize when I'm thinking through my type hierarchy, I want to make sure that if I have a bunch of behaviors that I want to be true of a whole set of my types, that I'm wise to use the type hierarchy so that I can implement the behaviors associated with all students, not individually in each student, but collectively in the superclass. Let's summarize what we've done. We've created a whole hierarchy of classes that implement the semantics we want associated with the different classes of people. So we have a person in general who has a name and a birthday. To that, we made a special type of person, a subclass of person, an MIT person that has an ID number. And then we created a subclass of that, which is all the different types of students, and then subclasses of students, which are either undergraduates or graduate students. And in this little diagram, I've used an arrow to point from a subclass up to its superclass. One final point about creating class hierarchies. We want to make sure that our subclasses obey the substitution principle. So for example, if I've written a bunch of code that deals with people, for instance, suppose I had a piece of code that looked at a person's age and put them into a histogram. What I want to be sure of is that if I have an MIT person or a student or an undergraduate or a grad student, or instances of any of the subclasses, that those instances can be used in every place that I could use a person instance. I don't want to somehow, in creating subclasses, to break the fact that the subclass is actually also an instance of the superclass. So, for example, if I change the getAge method on students so that it returned the number of years they've been at the institution rather than their chronological age, and then I tried to use a student in my person that made a histogram of chronological ages, that would break, because now getAge means something different for a member of the subclass of person, in fact, the student subclass. So in general, when thinking about overwriting, we want to be very careful. It's overwriting in order to add functionality with new methods is a great idea. Overwriting and changing old functionality might, in fact, violate our substitution principle, which is one of the key ways in which you can make object-oriented programs that actually fail to deliver on the promise of object-oriented programming.